Well, I've always joked about teaching an empty classroom and just hearing the math bounce off the back wall. But today I'm actually doing that, and it's not as fun as I thought it would be. I actually miss faces that smile when they understand, and the ones that frown and give you the evil look when they don't understand. But this is for, I have no mask on because there are no people here today, except for maybe some teachers down the hall. Students are without water, some are still without power. For those students that can do some of this and get to it, great. I'm going to put the college algebra practice test in Canvas today for you. And then I'm going to teach the discriminant now, which you've already seen the discriminant, you already know what it is, but it is all over the college algebra test in a lot of different forms. So we're going to do a quick review of what it does. And then if you will look through that, start working on the college algebra test that I'm going to put on Canvas. It'll be on an assignment down at the very bottom in your assignments list. It'll just say CLEP, and then I'll put day 1, day 2. Because this is what I was supposed to do in about 2 weeks. Since you're at home now, let's get on it. We'll take the CLEP test a couple weeks after you get back. I know you're going to ask me about pre-calc, so while you're doing that, I'll tell you, yes, we're going to take the pre-calc one too. But let's get college algebra out of the way first. Now, the discriminant is just that little part that you had when you were using the quadratic formula. You had ax squared plus bx plus c equals 0, and you used your quadratic formula, and you said x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, you've got to put the line under the whole thing or it's wrong. Okay? You've got to put that line under the whole thing. Honestly, I don't write it that way for students anymore because they end up messing up on the algebra afterwards. So I always tell them it's minus b over 2a plus or minus square root b squared minus 4ac over 2a. One reason I like to do this is it makes it easier for students to reduce. The other reason is if you remember the formula for a parabola, ax squared plus bx plus c, the vertex minus b over 2a. Right here. So this is finding where it would equal 0, so it's finding the x-intercepts if they exist. We're going to talk about what happens when they don't exist and how this discriminant affects that. But the deal is, now you end up with the vertex, how far you move to the right, adding to get your x-intercept, and how far you move to the left, subtracting to get your x-intercept. So the minus b over 2a is your vertex. Go to the right to find an x-intercept. You go to the left to find an x-intercept, add, subtract. But I think this formula is what we really should be teaching because it gives the student a better chance. I guess I'm teaching other teachers and my students now if I say something like that. All right, the b squared minus 4ac part. Well, there's 3 things that can happen with that. One is it's a nice perfect square. They all always like those. That means you could have factored though. Okay, so I'm giving you all that evil look even though you're not here because you should have factored it if that happens. You know that if b squared minus 4ac is equal to a negative, that some weird things happen because you have the square root of a negative. And then of course it could be positive, not a perfect square. And it could equal 0, which means you really should have factored. But let's talk about just the discriminant part now. Got enough review there of why it's important. Okay, the discriminant. It's the b squared minus 4ac part. It's just the part under the radical. Okay. Now, b squared minus 4ac. There's a couple things that could happen. It can be less than 0. b squared minus 4ac can be greater than 0. Oh, Mr. Evans did it in the wrong order because I want to put equal to 0 there. And then the only other option is b squared minus 4ac is greater than 0. That's the only three options you can have. Less than 0, equals 0, or greater than 0. If it's less than 0, you're going to get the square root of negative. So this will produce two complex solutions, two complex zeros. Oh, and we need to talk about this. Zeros or roots, according to which book you read. Two complex zeros or roots. And that pen's about to go, and I'm not going to put it back. Drop it right there. All right. Now, what this does mean, too, is there's no x-intercepts. Because the x and y axis are on the real numbers, and these two complex zeros or roots, i's. Okay? You got i's in there. You're going to get i's in your answer. Okay? Imaginary numbers, complex zeros or roots. But there's no x-intercepts. And that's for if you were solving ax squared plus bx plus c equals 0. Or if you were looking at x-intercepts, you'd be talking about the graph of the parabola. If you don't know that's a graph of a parabola, I'm going to go back and fail you for the last part of last year. Yes, I'm drinking a little bit of coffee. I'm missing my half students right now. Okay. And that's all that happens. You get a negative, there's no x-intercept, which is key to know, because that means the graph is either going to be like this, where it doesn't cross the x-axis, or it's going to be like this, and it doesn't cross the x-axis. Now, b squared minus 4ac equals exactly 0. You get two real, rational solutions. All right? And by rational, that means that they are a fraction 5 over 1. But they're two real rational solutions. They don't have any square roots left. It's just two real rational solutions. The problem is, I say two real rational solutions. It's two real rational solutions that are the same, are equal. Somebody's realizing on the video now I'm covering up for making a mistake. I was already teaching the next one, are equal. Sometimes books call it, you get a double solution. All right? Two rational solutions that are equal. In other words, if you were to factor it, you would get x equals 5, x equals 5. All right? That's what it means. You're going to get the same number twice if you were to factor it. Now, I really just should have said you get the same, you get one solution twice. Okay? That's called a double. Okay, double solution is what some books call it. You get one solution, but you get it twice. Or you get two real solutions that are equal. You get it twice. Now, and they are rational. All right? They're rational. No nasty bits that you can't take the square root of or anything like that. You can take the square root of 0, which is 0, by the way. Now, when you look at the graph, you have one x-intercept. These are the graphs for the parabola that end up looking like this. You have the x-axis and they come down, they touch, and they go back up, or they come up, they touch the x-axis and go back down. That's the kind of graph you get for b squared minus 4ac equals 0. So for b squared minus 4ac is less than 0, you never touch the x-intercept. Never touch the x-axis, no x-intercepts. B squared minus 4ac equals 0, you get that same number twice, two real rational solutions that are equal to each other. And then a double, or what's called a double solution. This is a little term that's, I hate to even call it that. I just tell you, you got a nightmare. You get 5 and 5 or 7 and 7. All right, now, and I'm going to try to make this look good. There's the first type. There's the second type. Now, for b squared minus 4ac is greater than 0, you get 2 real solutions. 2 real solutions. Shunts. Which also means you get 2 x-intercepts. Right there, x-axis crosses here, or you have x-axis and it crosses like that. But you get 2. 2 x-intercepts, 2 real solutions. Now, and this is where I'm going to give you a little bit more detail than you really need for the test, for the CLEP test, but you know, that ain't everything. If b squared minus 4ac equals a perfect square, that means 25, 16, 100, for those of y'all that are at home, equals a perfect square, you get 2 real rational solutions. Now I'm making sure that's showing up on the screen right there, 2 real rational solutions where I wrote it over there. So I'm walking back here to see if you can see that. You get 2 real rational solutions. Now, but they're greater than 0, so you're not going to get any i's. You don't get complex numbers. And if they're equal, you get a perfect square. All right? Show you an example of that. Let's say you worked all this out and you got 3 plus or minus 25 over 2. Let's put it over 2. Doesn't matter. Over 2. All right. Somebody says he's going to be back, see if he remembers the formula. Yeah. Well, see what happens there is you get 3 plus 5 over 2, which is 4. And you get 3 minus 5 over 2, which is negative 1. So you get x equals 4, x equals negative 1 if you work it all the way out. The discriminant is telling you what you would get if you were going to work it all the way out. Now, students in calc class will go, why didn't you finish that part over there, Mr. Evans, when they have this huge derivative equal to 0, and all of a sudden one end of it is in this form? And I go, oh, I looked at it and I did the discriminant in my head, and I realized the discriminant would be negative, so I know that's not going to give me real solutions. And if I'm looking at calculus for Calc 1 or Calc 2, I only care about real solutions. So a lot of times I'll look at it, I see that's going to be a situation where you're going to get I's, and I don't need those for the calculus class that I teach. All right? And then over here, you know, I do that, I see something nice. Okay? Now, if b squared minus 4ac does not equal a perfect square, now remember, we're already talking about just after it's what? Greater than 0. You get 2 real solutions. Now, if it's a perfect square and it's greater than 0, great. If it's a perfect square, it's not a perfect square, but it's greater than 0, here we go. You get 2 irrational I should have put the word real in there, 2 real irrational. I'm going to erase. This is getting real boring just teaching the wall. 2 real irrational. Now, some of y'all still have problems with the idea of what an irrational is and what a rational is. Rational is anything can be written as a fraction. Irrational, decimal never repeats, never terminates, and it can't be written as a good fraction. Somebody says, yes, it can, Mr. Owens, because pi is irrational, and they tell us to use 22 over 7. 22 over 7 is a good approximation. All right? That gives you a rational solution. Probably because, from what I understand, the Greeks didn't really like irrational numbers. They liked numbers that terminated or were fractions. But pi is irrational, decimal goes on forever, and all that. But there's the case for this. Now, these could be real numbers right here, or they could be, they're always going to be real numbers, but they could be rational or they could be irrational. In other words, you get the square root of 40, or you get the square root of 20, but you don't have a perfect square. And that covers all the cases of the discriminant, and adds a little bit of information over there. Somebody's going to, of course, want to not learn this, or I hate to use the word memorize, but if you don't know lots of details for the CLEP exam, you're in trouble. The CLEP exam is not like the ACT exam where you're good at math and you survive. The CLEP is final exam for college algebra at Tech. And can you pass the final exam for college algebra course at Tech? That's what it's measuring. It's measuring details of information. What's taught in a specific course, not, oh, I'm good at math. Okay, that's enough of that speech. But that is the discriminant, and that's how it works. I'm going to post the video in the assignment. And I'm also going to post the pages out of the CLEP. Now, honestly, since I'm trying to teach class here and maybe put something out there for somebody who needs discriminant that's not in one of my courses, if you're taking the ACT in April, right now you're at home for 3 days. You might want to be pushing the ACT study guides that I've been giving you, that we don't cover in class. Or, if you know you're going to take this test, which I want all of you to take anyway, because if you pass it, you're going to be exempt from the final in here with an A on the final, 99% on the final. Okay, if you score perfect CLEP, I'll give you 100. But you pass the CLEP, I'm going to give you a 99 on the final. That may make you want to study this. Spend the next 3 days prepping for one or the other. This is on the ACT. The discriminant part's on the ACT too. So either one's going to help you. This is better, I think, than the ACT review if you do the CLEP, because it'll get you through everything that's on there except for the trig. And we've started trig, and we're hitting trig pretty good. And I'm proud of y'all. Be careful, be safe, and I will see y'all in class on Monday.